Hello, this is the first of a sequence of 3 videos on hydrocarbons. This first video is on crude oil, the next one will be on natural gas, and then the third one on coal. Okay, so let me point you to the handouts, to the most important parts in the handouts. So we start this section on crude oil with a brief overview. Please read through this. Crude oil is traded in barrels, as you know, which is a measure of volume. So 1 barrel, which is abbreviated like this, contains 42 gallons, which is this amount of liters. Okay. This is a brief description of the market participants. Please read through this. And here it's an important part about types of crude oil. So there are many different types of crude oils, and they are distinguished by these 2 important properties. The first one is the sulfur content. This is a bad characteristic. We do not like oil with sulfur because it's a pollutant. So there are 2 types of oil: sweet crude oil that has little sulfur in it, and then sour crude oil, which has more sulfur. So these terms, it's called like this because people used to drink oil in the old days. There was even a saying that said that a cup of oil a day keeps the doctor away. So sometimes it tasted sweet, other times it tasted sour. No, I'm joking. I have no idea where do these names come from. By some reason, it's called sweet and sour. I don't know why. A second property is the density, which basically there are 2 types of oils: light oils and heavy oils. The important part here is that light oils are more expensive. And the reason for that is that they produce more gasoline. Okay? And furthermore, they are also of the first kind. They are also sweet, usually. Okay. So the 2 main benchmarks that we have in the market today are these 2 that you see here: West Texas Intermediate, which is the benchmark for the US market, which is of the good kind, in the sense that it is light and it is sweet. The second one, which you also hear about in the news very often, is Brent. And this is also of that same good kind. It is also light and it is sweet. Okay, and this is the benchmark for Europe and for many other international markets. Right? Okay, the refining process. It's in very simple terms, it's just what you see here. And basically it just means that oil goes in, and then on the other side of this distillation column comes out all these different products, from gas to gasoline to diesel and other stuff. I mean, it's a relatively simple process. It has been known for many centuries. But obviously nowadays, if you look at a refinery, it's a big industrial plant, because this process is optimized to take as much as possible from oil. Okay, increase this a little bit to make the video easier to see. All right. There is an interesting equilibrium here, in the sense that you will see 2 types of refineries. You will see what we can call simple refineries, in the sense that they don't spend very much on equipment. They have smaller initial capital costs, and then they use the more expensive crudes, the ones that are able to output more gasoline. So it's a low initial cost, but then higher variable costs. Then you also have other types of refineries, which we call complex refineries, which do the opposite strategies. So they spend more in the beginning on the initial investment in capital. It's larger, and then they buy the other type of oils, which are cheaper. But since they have a lot of equipment, they are able to process those oils very well, and actually get a lot of gasoline out of that. So it's a trade-off here, the sense that they spend more in the beginning, then they spend less as variable costs. So there are these two types in the market, and we'll discuss this a little bit later in this chapter. The main refined products are gasoline and diesel. Diesel fuel is sometimes called heating oil, which they're not. Diesel and heating oil is not exactly the same thing, but it's very similar. And when we get to derivatives, the derivative that we use to hedge is exactly the same. So these products are mainly used for transportation, as you know. But another interesting application that we have here is to use diesel for electricity generation. So the example is the following. We have a diesel peaker, which is basically a power plant that uses diesel to generate electricity. The peaker term means that it is only going to be used when we have peak demand of electricity. So it's, as we'll see, it's very expensive to use this. So it's only used when it's really, really necessary because everybody's using electricity at that moment. It converts diesel fuel to electricity with an efficiency of 20%. So this means that for each unit of energy in the fuel, only 20% shows up as electricity. This is a property of every generator. The amount of energy that you put in is always more than the amount of energy that comes out in the form of electricity in this case. Right? So the remaining, in this case, the remaining 80% is wasted. How is this wasted? Well, it comes out in the form of heat. This is basically just like a car engine. Right? You put in gasoline and the car moves forward, but if you look at the engine of the car, after some time it's very hot because there is a lot of energy that is wasted in the car. And here it's exactly the same thing. A lot of it is just wasted as heat. Right, so we need to know what is the energy content of diesel. This is called lower heating value or net calorific value, and we can in our problems this is going to be given, but this is something that can be measured. And for this particular diesel, it has this this energy content. So it means that if you start with 1 gallon of diesel, okay, so this given quantity of diesel, if you burn it, the amount of heat that comes out is this 136 megajoules. So this is the amount of energy per 1 unit of volume of diesel. And then this is the price of diesel. Like if you go to the gas station, you see there on the gas station that gasoline or diesel costs some amount per liter. Here in Europe or in the US, it would be some amount of dollars per gallon, right? So now the question is, if we want to use this diesel peaker, how much does it cost to generate 1 unit, so 1 megawatt hour of electricity? Okay. Recall we in the previous chapter when we talked about units of energy, we looked at this conversion between kilowatt hours and megajoules. Okay. So this example here, it's very detailed. We will do a lot of examples, different applications, but the same type of calculations. But this first one is in all the details so that we can go through this slowly. Right, so basically, step by step, you want to find what is the cost of generating one unit of output, right? So given that there is a 20% efficiency, you know that the energy that comes out is only 20% of the energy that goes in, right? So you want to get 1 megawatt hours. This is how much it needs to come out, which means that the energy that has to go in is the inverse of this 0.2 times 1 megawatt hour. So if you put in 5 megawatt hours, given 20% of efficiency, you are left with just the 1 megawatt hour that you want to come out. Okay. So basically, what we now need to do is to find what is the cost of diesel that gives me 5 megawatt hours of energy. So what is the cost of that energy that goes in? So it's 5 megawatt hours times. So I'm first, before going directly to cost, I'm going to first convert this quantity of energy into the equivalent amount in diesel, right? So I know that diesel has this amount of energy per gallon. So what I need to do is to multiply this here by some number that will convert this amount of energy to a different amount of energy in diesel, and then from that to an amount of volume of diesel, right? So think through this at home, and then we can discuss in class what you need to put in here. Actually, the solution is down here, so we'll talk about it in a second, but try to stop the video now and think, what do you need to multiply here to get this amount of gas? Of diesel. So once you know how much diesel you need to get 5 megawatt hours of electricity, you just need now to multiply this by the price. So this amount of gallons times the price that you have here will give you the total price of diesel that you need to input 5 megawatt hours of energy. That will give you a 1 megawatt hour of output. All right, and that number is this. Right, so this is the price. I'm sorry, this is the cost of generating 1 megawatt hour. Okay. So either go through this in these 5 steps, or we can do this in one single go. So the cost of 1 megawatt hour, the final result, is going to be what? It's going to be the total amount of energy that I need to have on the input, which is the inverse of the efficiency, and then convert that to the amount of gallons that I need to have of diesel, right? So basically this expression here corresponds to what you need to put here, okay? And then once you have all that stuff here, which is 132 gallons, multiply by the price of 1 gallon to get the total cost. Okay? So again, look at this and then let me know if you have questions in class. All right. Markets and prices. There are interesting relations between the prices of oil and the outputs. Read through this. We will actually explore this further when we get to derivatives, and we'll see how to trade on these relations between the prices. This is also an interesting point about how the markets are different. Crude oil, it's a globally integrated market, whereas refined products are not integrated. They are regional markets, right? And again, read through this. Okay, another important point is the crack spread. So the crack spread is basically just the difference. It's for a refinery, it's just the difference between the price of the output minus the price of the input. So it's basically an estimate for the gross profit of a refinery, okay? Expressed in dollars per 1 barrel of input. So basically what we're going to do is to see how much does it cost to buy 1 barrel of oil, and what is the value of the products that we can get from 1 barrel of oil. So as I told you, there are different types of refineries, and the types of refineries are described by these types of ratios. What this means is, for example, here, if you use 3 barrels of oil, you can get 2 barrels of gasoline and 1 barrel of diesel. Or here, if you use 5 barrels of oil, you can get 3 of gasoline and 2 of diesel. Okay? These different ratios come, again, from the different strategies that refineries can follow, that different mix we talked about between initial investment, and the type of oil that they use. So the calculations here are pretty simple. So in this example, suppose that we have a 5:3:2 ratio. Again, this is oil, gasoline, diesel, and that these are the current market prices. WTI is the price of oil, $50 per barrel, and gasoline, let's say it's at $163 per gallon, and diesel at $158 per gallon. Okay. So what is the gross profit of this refinery? What is the crack spread? So the calculations are very easy. Just see how much does it cost to buy 5 barrels of oil, which is the common denominator here. You see how much is the revenue from 3 barrels of gasoline. So here you just have to be careful that from 5 input you get 3 barrels of output, but then the price of gasoline is given in dollars per gallon. So you need to convert from barrels to gallons. Okay, and the conversion is simple. 1 barrel is equal to 42 gallons. Okay. Likewise for diesel, and then subtract the values of the outputs. Do the values of the outputs minus the value of the input. This is the total for 5 barrels of input. Divide that by the 5 barrels of input and get the crack spread per barrel of oil. Or, I mean, you can do this in a very simple way as well. Just do it in one simple expression. This is basically just a weighted average of the output minus the cost of the input. Right? So these crack spreads are important. Again, when we get to the chapters on derivatives, we will see how to trade these spreads and how to hedge the profit of a refinery. All right, and that's it.